So this week we're going to be covering the 200 LeetCode problem, number of islands. This problem, I have seen it way too many times in my interviews and my friends' interviews and my friends of friends' interviews. I've been asked this question when I was applying to this biotech company called Flatiron, as well as for Google. Some of my friends have been asked this question when they were applying for tech companies like MongoDB. So this is probably one of the most popular questions ever asked in any sort of interview setting. Let's dive right in by reading the problem statement. Given a two-dimensional grid map where ones represent land and zeros represent water, count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So let's just take a look at these two examples. In the first one, we have one island because these ones are connected horizontally, and then there is a one that represents land also connected vertically this way, and there are some more ones connected vertically and horizontally this way. Now let's take a look at example 2. Here we have 3 islands. So we have an island here that is connected horizontally and vertically, then there's another island right over here, and finally there is one more island over here. Cool. How can we convert this information into an algorithm? Let's take a look. Suppose we're given a graph that looks like this. We can see clearly that there are 3 islands that can be discovered. Here, here, and here. So how can we actually find these islands? So because we know this is a graph, what we can do is perform a sort of depth first search. Now the problem that we're going to run into is keeping track of which values we've already visited. So to combat that, we can easily have a visited array that is of the same size as the islands array, and inside of it we can just track whether or not we have visited a specific node. Starting off, we're going to start with the initial node. In this case, that's the ij pair of 0, 0. In this case, it is 0. So we're just going to mark that visited and not perform a depth first search because it is a 0. So we can visit the next node and mark it visited, and it's because it is a 1, we can perform a depth first search on this node. How are we going to do that? What we can do is from 1, we can go 1 index up, 1 to the left, 1 to the right, and 1 down. So when we go up, we're going to know that that is out of bounds. When we go to the left, we're going to see that it has already been visited. When we go to the right, we're going to see that it is a 0. So we can just mark that visited. And when we go down, we're going to see that this value has not been visited and it's a 1. So we're going to mark that check, and because it's a 1, we're going to perform depth first search from here. So again, we're going to check up because it's already visited. We do nothing when we go up. Then we check to the left because it has not been visited yet and it's a 1. We can mark it check and perform DFS on this 1. So when we're performing DFS, we look up, see that it's been visited. We look to the left, see that it is out of bounds. We look down, we see that it is a 0, so we mark that visited, but we don't count it as part of the island. And finally, we recurse back up to this node and proceed to look right, and when we look right, we see that it is a 1, so we mark that visited, and we perform DFS on this 1. So on this one, we look up, left, down, and right, and we know that when we're looking down and right, we have to mark them visited, but they're all 0, so it does not matter. So then we recurse back to this node 1, and we finally check the down value here. Since it is 0, we don't need to recurse on it, and we can just return back to the original 1 over here. So now our visited array is going to look like this, and that is because we've already visited a lot of these nodes. And then now we have performed a check on here and here, so now we're going to go here, but we're going to see that it's already been visited, so we're not going to do anything. And then we're going to start our check here on this 1. We're going to try to recurse left, up, right, and down, but we're going to notice that they're all 0s or out of bounds. So all we're going to do is mark this visited and this visited, and we're going to keep going through in this algorithm one node at a time, making sure that we visit every single one. And the next time we have to actually perform a DFS, we're only going to be performing a DFS right over here. Of course, we have to mark that check and perform DFS. So we will mark these values checked as well. And finally, we will continue to finish the matrix. And the important thing to note is that whenever we perform a DFS, we just increment a count. And that's just going to count the number of islands that exist. So if we ever perform a DFS, we just increase the count by 1. because we performed DFS 3 times, there are 3 islands. Cool. Now let's jump into the time complexity and space complexity. We know that we're going to have to iterate through all of the values inside of this 2-dimensional array, and this 2-dimensional array can be of size n squared. So the time complexity quickly becomes n squared. Additionally, we are keeping track of all the values that we have visited, and this visited array is going to be the same size as the islands array. So we are going to have a space complexity of n squared as well. Now, an important thing to note is that we actually don't need this entire visited array. We don't need it because we can just change the values inside of the islands array. If we have visited them, we can just, instead of leaving them as 0s or 1s, we can change them to something like percent symbol, and that can allow us to minimize the space complexity from O of n squared to O of 1. However, that would mean that we are changing the islands array, and we might not want to do that. Whenever I would solve this problem in interviews, I would actually just have a visited array. But I did notice that in LeetCode, there was a solution, which I'll link in the description below, where the user did not have this entire visited array, and it saved a lot of space. So that is something that we can use for our solution as well. And I'll be using that when I go through in my coding example. So in my coding section, I explained that I always used a visited array to keep track of which nodes I've already visited. However, there was a solution in the discussion made by this person where he basically didn't do that. So he just changed the value from 1 to a character to represent that it's been visited. Now this is usually fine, at least for the case of LeetCode, and so that is why I also did the same thing in my approach. Doing this in a real interview setting, you may want to keep track of the visited array because you don't want to change the actual 2-dimensional grid that you're given. So let's just jump into the code. So we have a count which we're only going to increment if we ever perform a DFS. We go through the matrix in a nested for loop, and what we do is check if ever the grid has a value of 1. If it is, then we perform a DFS on it, as well as increment the count. When we're performing a DFS, all we do is check row +1, row -1, column +1, column -1 values, because that represents the vertical and the horizontal values that are either to the left or to the right or to the top or to the bottom of the specific land node that we are on. And if it is the case that either it is out of bounds, or so either it is out of bounds on the left side, or it is out of bounds on the right or top side, or the value itself is not equal to 1. If it's not, then we just return. Otherwise, we can just change the value in the grid so that when we're iterating through in a future step, we don't accidentally try to traverse through or perform DFS on an island that has already been seen. So that is why we're going to convert these into a different character. Finally, all we're going to need to do is return the count, because the count is going to contain the number of times we performed DFS. And when we're performing DFS, we're going to just be changing all these values into a different character, not 1. And that is going to pretty much handle the solution for us. So let me just real quick go ahead and submit. And of course, it is a success. Cool. Thanks for watching. Hope you guys enjoyed. If you did, leave a like and subscribe for more in the future. I post weekly on Mondays. Awesome. I'll catch you guys next time.